Hello everyone, welcome yet again to CPRict. In this video, we would be explaining a problem which occurred in today's LeetCoding August challenge. That is the August LeetCoding challenge. And one disclaimer here, if you are not aware with dynamic programming, then this video might not be suitable for you. So yes, let's see what is the problem statement. It is called minimum cost for tickets. It says in a country popular for train travel, we have planned a some journey in which we'll be traveling via train, and we need to book our tickets 1 year in advance. There are three types of tickets which we can buy. One is 1 day pass, 7 day pass, or a 30-day pass, and this would be consecutive days, and we have the respective costs mentioned here. And yes, there would be 365 days in that year. We have been given a days array which tells us for which days, what are the days on which we want to travel, and we can only buy these three type of passes, and we need to buy all of those passes by right now, like 1 year in advance. For example, what it says is the pass is for consecutive travel. For example, if we buy a 7-day pass on day 2, then it will be valid from day 2 to day 8 only. Even if we do not want to, or we do not wish to travel in between these days, it does not matter, but our pass will only be valid till day 8. They do not care about us, no. So we need to return the minimum number of dollars which will be needed to buy or book the tickets for 1 year in advance. Let's see one example here. These are the days on which you want to travel. This is the cost array, the cost for 1-day pass, 7-day pass, and 40-day pass respectively. And what we can do here is buy a 1-day pass on day 1, then buy a 7-day pass on day 4, which will cover these 4 days in between, and then on last day we can buy a 1-day pass on day 20. Now keep in mind one thing which we need to focus right here. Suppose we just want to buy a travel for 1 day. It does not mean that we should buy the 1-day pass only, because there might be few test cases in which the money for the 7-day pass would be lesser than the money needed for 1-day pass. I know it is not logical, but as it's a coding problem, so we should cover all those cases. So yes, here the minimum money we need would be 2 plus 7 plus 2, that is 11. Also we could have bought the second pass on day 3. It also would have covered for the day 4 to day 8 all these days. Yes, so let's see what we can do to solve this problem. First of all, you guys should be aware with dynamic programming. I won't be going into details of dynamic programming, but let me just tell you a brief overview of what dynamic programming is. Now for us or for anybody to use dynamic programming, two conditions need to be satisfied. The first one is optimal substructure, and the second one is overlapping subproblems. Yep. So by first one, the first condition, what we mean is, suppose we want to find out the answer for some recursive call or some problem, and if we are making recursive calls on smaller subproblems, let's say these are the smaller subproblems on which we are calling. then the optimal solution we get of these smaller subproblems should be we should be able to use the optimal solution of these smaller subproblems to build up the optimal solution of the bigger subproblems. Okay, it is also similar to induction part. It is called optimal substructure. And the second one, here we have the second condition we have is overlapping subproblems. Here also let me just explain you using a high level diagram. Suppose we have two recursive calls. These are two separate recursive calls, and they are making another recursive calls on smaller subproblems. Let's say these are the ones. Also this is the one, and let's call them A, B, C and B, C, D. So if we execute all these smaller subproblems individually, then we would be seeing that we would be executing all these smaller subproblems, and it will take a lot of time. And if you see, we are for smaller subproblem A, B, we are executing it twice. But do we need to execute it twice? No, this is not the case. What we can do here is, whenever we are at a new subproblem, that means which has not been solved yet, what we can do, we will solve it once and store its output in some data structure. Let's call it DP. We will store its answer here. Let's call it X, and for subproblem B, let's call its answer PB, and we will store its answer here. Now whenever in future we see a situation when the same problem needs to be processed, or we want to find the answer for the subproblems B and C. Here the B and C, not A and B, because B and C are overlapping. Then we will just we won't be executing the same subproblem. What we will go to this array, the data structure array, and return these answers. Simply return this. So then after executing it once, we can find their answer in constant time. It is called dynamic programming, as its name specifies or indicates dynamic. Like, it means dynamically we are choosing whether we should be executing it once, or we can just use the value stored at some data structure. So this is all. That's all for the overview of dynamic programming. And also there is another thing which I think I should tell you guys. So whenever we are doing a recursive call, I am explaining dynamic programming in terms of recursion. Like, whenever we are doing recursive calls, there are cases when we can also use dynamic programming using an iterative approach using loops and all, but here we are only talking about recursive approach. And during recursion, suppose we have a function which is a recursive function, and it has some arguments x, y, z. Then there are some arguments which which uniquely signifies a particular recursive calls. For example, if we are calling our recursive function on index I, so this index I will tell us on which like this index can be used to uniquely identify a particular recursive call. Also there can be more such arguments. Like, we can have a combination of x, y arguments which will uniquely identify a recursive call. Now these arguments are called states. What these are telling is, they are telling us the state of this recursive call. Like, and using these states we are able to find out whether we have solved this recursive call earlier or not. And if we have not solved it, we will solve it. Otherwise we will just return the answer stored in that variable. So this is for that's it. This is all for the states part and this dynamic programming overview. Now let's see what we can do here to solve this particular problem. Yep. So here we have days. As you can see here, the length of days array is maximum 365, and our cost, yes, 365. That is, we will be booking tickets for at most 365 days. So let's first identify our states for a particular recursive code. First would be the days. That is the day at which, or on which we want to travel, or we want to book our ticket. And the second one would be remaining tickets. Yep. Suppose we have bought a 7-day pass on day 1. Then after day 1 we have 6 remaining days on which we do not need to buy the pass again. This is the remaining tickets which I am talking about. And yes, again, suppose we have bought the 7-day pass on day 1, then on day 5, on day 5 our remaining tickets value would be 4. So I think these two values can be used to uniquely identify or determine our recursive call when it comes to this problem. Okay, these are the two states. Let's see the ranges of these states. As it has been mentioned, then the ranges of days would be from 0 to 365, and at most we would be booking our tickets from 65 days. And remaining tickets, as you see, we have 3 types of passes: for 1 day, for 7 day, and for 30 day. So maximum number of remaining days can be 30. This is the range of our DP array. I think it is okay. It won't cause any stack overflow or heap overflow, and also no, it will not cause any TLE, as the maximum number of sub problems we could have here is 365 into 30, and it is under our control. Now let's try to solve our problem. Yeah, so suppose we are on the day array. Let's take the example which was mentioned here: 1, 4, 6, 7, 8, 20. 1, 4, 6, 7, 8 and 20. This days here is the index of the day we want to book our ticket for. Okay, so for here the index is 0, 1, 2, 3, 4, 5. We will be able to fetch the value of that particular day using the indexes. So we will kind of reducing our time complexity here. So first of all, we will see, suppose we are on some let's call it IDX, the index which I am talking about. So whenever I am on a function IDX and the remaining days, let's call it remaining tickets. If the remaining tickets is equal to 0, it means we do not have the pass to travel on this particular day, on whatever day we are currently at. So at this day, if we have remaining tickets as 0, it means we need to buy a pass. There is no way we will be able to travel without it. And there are three choices we are having. We can buy a 1-day pass, 4-day pass, oh sorry, not 4-day, 7-day pass, or a 30-day pass. And then what we will do, we will add the cost of these passes respectively and call the recursive function on the index IDX plus 1, similarly here, and update the remaining tickets as well. Remaining tickets will also be updated according to the type of pass we are buying. I will explain it using my code, and we will take the minimum out of these 3 calls. We'll store our answer here because we want to find out the minimum cost. Okay, this is for the case where remaining ticket is equal to 0. And when we see that remaining ticket is not equal to 0, it is greater than 0, it means we have the pass we have the pass to travel on this current day. Okay, then we will just proceed with our recursive call and go to idx plus 1 and also update our remaining tickets. The way we would be updating, I'll just tell you, I'll just explain that in a while. This is for the case where remaining tickets is greater than 0. Yeah, now let's see how we can update our remaining tickets. Now suppose we have our days array, and the value on this days array is 1, 4 and 10, and I am here at this index I, it is equal to 1, and I have at this point I have remaining tickets as 0. So we are sure that we must buy some ticket on this day, as we do not have any store tickets or left tickets, any remaining tickets at this point. So there are 3 choices what we can do. From index 1 we can move. First of all, we need to add the cost for buying 1 day pass, and then we can go to idx plus 1, and the remaining tickets, if you see, as we are only buying a 1 day pass, it will only be valid for this day only. From next day onwards it would be 0 because we do not have any remaining tickets. So this is it for the first case. For the second case, when we are buying the 7 day pass, we will add the cost for the 7 day pass, plus we will go to the next day, that is the one that is in our day array. That is why I am doing idx plus 1. idx plus 1 does not mean I am going to the next day, I am just going to the next value in our day array. And to update the remaining tickets, now I will be saying what is the next day on which I want to buy a ticket. Here we have 10 and the current day is 4. I will just find the gap, the number of days in between these two values. It comes out to be 6. And now if we see, if I include the day here, the current day 4, because I need to buy the ticket for day 4 also, then it turns out it is 7 days. Let me see, 4, 5, 6, 7, 8, 9. There are 6 days if we include 4 as well, not 7, my bad. So if we find out the gap, it is 6. So 6 includes 4 as well. What we would be doing for if we have bought a 7 day pass, we will just do 7 minus that gap. I call it gap, this value 10 minus 4, and in this case it is 4 minus 1, that is 3. I am calling it a gap. So I will just do 7 minus gap. In this case, if I do, I'll see 7 minus 6. So at 10th day 10, I still have my remaining tickets as 1. Okay, this is the way I updated it. In the third case, for a 30 day pass, I'll just do cost 30. Cost of, actually in array it is cost 2 because it is at the second index. I'm just writing cost 30 to explain what I am doing. Go to idx plus 1 and I will do 30 minus gap. So if I had done 30 minus gap, the gap is 6 here, as the next day is 10 and the current is 4. Then for the next recursive call, the remaining tickets would be 24. It means on day 10 I still have 24 tickets remaining at this point. So I am passing this info to my next recursive call. I hope you have understood the remaining tickets part, how I am updating it, and the days. This idx plus 1, again I am telling it, it is not day plus 1, it is I am moving forward by 1 index on my days array. Okay, and I have also explained the gap and the remaining. Yeah, I think that is all I need to explain. Let's move to the code part now. Yeah, this is the DP array which I have initialized. I have explained the size, why I have used this size, and initially I am initializing all the values as -1 so that it can tell me that I have not, if I find that for any recursive call the value of DP array is -1, it means I have not found, or I have not executed the recursive call for that particular state. So I'll do it. If it is not equal to -1, it means I've already executed it earlier. I'll just use the stored value, and this is the number of days, so I'm calling it on my helper function, which is this one, sol. This is the index which tells us at which index our days array we are at. So here 0 1 2 3 4 2, this last one, these are the days, but this is index, this is different thing. Remaining tells us the remaining tickets we are having. If remaining less than 0, we will just update it as remaining 0. Now there can be case where remaining is less than 0. Let me just tell you what are those cases, or just give you one such case. Suppose we have the days array and the value in this days array is 4, and the next day we want to buy ticket is 15, and we are buying a 7-day pass from this day. Now what we would be doing, we will find gap, which is 15 minus 4, it is 11, and we would be doing 7 minus gap, that is after starting from 4 I have the tickets for 4 plus 7 minus 1 days, that is to 4 to 10 days. Like from day 4 to day 10 I have the ticket. So if I do 7 minus gap, here it is 7 minus 11, it turns out it is negative. It means for the if we go to the day 15, we do not have any ticket for this day, we need to buy it for that day. So if it is less than 0, I am changing its value to 0. If it is the last index, that is I am at the last index of my day array, the last day to which I want to buy a ticket or I want to travel on, if I see there is some remaining tickets still, then I do not need to buy new tickets, I'll just return 0. And if the remaining is 0, it means I need to buy a ticket for that, even for the last day, and I'll take the minimum out of these 3. That is the C is the cost array of these 3 passes for 1 day, 7 day and 30 day tickets. And if I see the value of this TP array is not -1, this is where I'm using the dynamic programming and just returning the stored answer. And now I found the gap which I have just explained. Like here the gap is 15 minus 4, that is 11. Found the gap. I see if remaining is equal to 0, then I need to buy the ticket for this day. So what I'm doing is I'm buying a 1-day ticket, going ahead with my recursive call, or I'm buying a 7-day ticket and going ahead with my recursive call. As you can see, I've done 7 minus gap. Or the third option I have is buy a 30-day pass and go ahead with my recursive call, and I'm taking the minimum out of these 3. One thing we need to focus in on recursive, for any recursive solution, we need to trust in the subproblem calls. Like whenever we are calling our function or smaller subproblem, like here idx plus 1 to n is a smaller subproblem as compared to idx to 1. So we need to believe this recursive call will give us the correct answer, and we can use other infos like here C0 and all to build up the solution of this current problem, which is idx to n. Yep. And if remaining is not equal to 0, it means we have the ticket for this day. Yeah, we have the ticket because we must have bought it earlier. We do not need to buy it again. We'll just go ahead with our recursive call, that is idx plus 1, and we will do remaining minus gap once again. Because we are moving ahead, we need to neglect or remove the days which come in between. Okay, so yep, that's all for this video. I hope you understood something about dynamic programming if you are not aware with dynamic programming. And if you like our videos and learning something from it, then please like and subscribe to our channel. Till then, take care. Sayonara.